Electrical engineering is a field concerned with the study and application of electricity, electronics, and electromagnetism. It covers a wide range of topics from the design of integrated circuits to the development of power systems. Understanding fundamental concepts is crucial for anyone entering this field. Let's begin with basic electrical circuits. An electrical circuit is a closed loop that allows electric charge to flow. It typically consists of a voltage source, conductors, and components that consume or store energy. The fundamental quantities in electrical circuits are voltage, current, and resistance. Voltage, measured in volts, is the electrical potential difference between 2 points in a circuit. It represents the force that drives electric charge through the circuit. Current, measured in amps, is the rate of flow of electric charge through a circuit. It represents the amount of charge passing a given point per unit of time. Resistance, measured in ohms, is the opposition to the flow of current in a circuit. It represents the ability of a material to impede the movement of electric charge. Ohm's law is a fundamental relationship that relates voltage, current, and resistance. It states that voltage is equal to the product of current and resistance, or volts equals amps times ohms. This law is essential for analyzing and designing electrical circuits. Resistors are components that provide resistance in a circuit. They are used to limit current, divide voltage, and dissipate power. Resistors come in various values and power ratings. Capacitors are components that store electrical energy in an electric field. They consist of two conductive plates separated by an insulator. Capacitors are used to filter signals, store energy, and provide timing functions. Inductors are components that store energy in a magnetic field. They consist of a coil of wire. Inductors are used to filter signals, store energy, and create oscillating circuits. Kirchhoff's current law, KCL, states that the algebraic sum of currents entering a node or junction in a circuit is equal to zero. This law is based on the principle of conservation of charge. Kirchhoff's voltage law, KVL, states that the algebraic sum of voltages around any closed loop in a circuit is equal to zero. This law is based on the principle of conservation of energy. Series circuits are circuits in which components are connected end to end so that the same current flows through each component. The total resistance of a series circuit is the sum of the individual resistances. Parallel circuits are circuits in which components are connected side by side, so that the voltage across each component is the same. The reciprocal of the total resistance of a parallel circuit is equal to the sum of the reciprocals of the individual resistances. Circuit analysis techniques are used to determine the voltage and current in various parts of a circuit. These techniques include nodal analysis, mesh analysis, and superposition. Nodal analysis is a technique that uses Kirchhoff's current law to solve for the node voltages in a circuit. Mesh analysis is a technique that uses Kirchhoff's voltage law to solve for the loop currents in a circuit. Superposition is a technique that allows you to analyze a circuit with multiple sources by considering the effect of each source independently. Alternating current, AC, is a type of electrical current that periodically reverses direction. It is the type of current that is commonly used in power grids. Direct current, DC, is a type of electrical current that flows in one direction only. It is the type of current that is produced by batteries and solar cells. Electrical power is the rate at which electrical energy is transferred in a circuit. It is measured in watts. Power is equal to the product of voltage and current, or watts equals volts times amps. Electrical energy is the amount of electrical power used over a period of time. It is measured in kilowatt-hours. 1 kilowatt-hour is equal to 1000 watts of power used for 1 hour. Transformers are devices that transfer electrical energy from one circuit to another through electromagnetic induction. They are used to step up or step down voltage levels. Diodes are semiconductor devices that allow current to flow in one direction only. They are used in rectifiers, switches, and voltage regulators. Transistors are semiconductor devices that can amplify or switch electronic signals and electrical power. They are the fundamental building blocks of modern electronics. Operational amplifiers, op-amps, are integrated circuits that can amplify signals and perform various mathematical operations. They are used in a wide range of applications, including audio amplifiers, filters, and control systems. Digital logic circuits are circuits that operate on binary signals, which represent true or false values. They are used in computers, microcontrollers, and other digital devices. Microcontrollers are small, self-contained computers that can be programmed to control various devices and systems. They are used in embedded systems, robotics, and automation. Electrical safety is an important consideration in electrical engineering. It is important to follow safety precautions when working with electricity to prevent electric shock and other hazards. Grounding is a safety measure that provides a low resistance path for current to flow in the event of a fault. It helps to prevent electric shock. Fuses and circuit breakers are overcurrent protection devices that interrupt the flow of current in a circuit when it exceeds a safe level. They help to prevent fires and other damage. Electrical codes and standards are sets of rules and guidelines that govern the design, installation, and maintenance of electrical systems. They are designed to ensure safety and reliability. The National Electrical Code, NEC, is a widely adopted standard for electrical installations in the United States. Article 310.15 addresses ampacity of conductors. Ampacity refers to the current carrying capacity of a conductor, typically expressed in amps. It represents the maximum current a conductor can carry continuously under specified conditions without exceeding its temperature rating. The NEC provides tables and guidelines for determining the ampacity of various types of conductors based on factors like conductor material, size, insulation type, and ambient temperature. These tables, such as NEC Table 310.15, take into account factors that can affect the conductor's ability to dissipate heat. The ampacity of a conductor is crucial for selecting the appropriate size of conductors for a given application. Using conductors with insufficient ampacity can lead to overheating, insulation damage, and even fires. Derating factors are applied to conductor ampacity to account for conditions that can reduce the conductor's ability to dissipate heat. These conditions may include high ambient temperatures, multiple conductors bundled together, or conductors installed in conduit or raceways. Derating factors are specified in the NEC and must be applied to ensure the safe and reliable operation of electrical systems. Voltage drop is the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to a certain percentage of the source voltage. Calculating voltage drop involves considering the conductor's resistance, the length of the conductor, and the current flowing through it. Proper conductor sizing can help minimize voltage drop. Short circuit current is the high current that flows during a fault condition, such as a short circuit. Short circuit currents can be many times higher than the normal operating current of a circuit. Overcurrent protection devices such as fuses and circuit breakers are designed to interrupt short circuit currents quickly to prevent damage to equipment and wiring. Calculating short circuit current is essential for selecting the appropriate overcurrent protection devices. Ground fault current is the current that flows through the grounding system during a ground fault condition. Ground faults occur when a live conductor comes into contact with a grounded surface or enclosure. Ground fault circuit interrupters, GFCIs, are devices that are designed to detect ground fault currents and interrupt the circuit quickly. GFCIs are required in certain locations, such as bathrooms and kitchens, to protect against electric shock. Electrical drawings are used to represent electrical systems and circuits. They provide a visual representation of the components, wiring, and connections in a system. Electrical drawings typically use symbols to represent different electrical components. Understanding electrical drawings is essential for electricians, engineers, and other professionals who work with electrical systems. Single-line diagrams are simplified electrical drawings that show the major components of a power system, such as generators, transformers, and circuit breakers. They are used to provide an overview of the system. Wiring diagrams are detailed electrical drawings that show the connections between individual components and devices. They are used for installation and troubleshooting. Ladder diagrams are a type of electrical drawing that is commonly used for control circuits. They show the sequence of operations of a control system. Programmable logic controllers, PLCs, are industrial computers that are used to automate industrial processes. They are programmed using ladder logic or other programming languages. PLC are used in a wide range of applications, including manufacturing, robotics, and process control. Human-machine interfaces, HMIs, are devices that allow operators to interact with PLC and other control systems. They typically consist of a display screen and input devices such as buttons or touchscreens. HMI are used to monitor and control industrial processes. Variable frequency drives, VFDs, are devices that are used to control the speed of electric motors. They work by varying the frequency of the voltage supplied to the motor. VFD are used to save energy and improve process control. Power quality refers to the characteristics of the voltage and current in a power system. Poor power quality can cause equipment to malfunction or fail. Power quality problems include voltage sags, voltage swells, harmonics, and transients. Power factor is a measure of how efficiently electrical power is being used in a system. A low power factor can result in increased energy costs and reduced system capacity. Power factor correction can be achieved by using capacitors or other devices. Harmonics are distortions in the voltage or current waveform that occur at frequencies that are multiples of the fundamental frequency. Harmonics can cause equipment to overheat and malfunction. Harmonic filters can be used to reduce harmonic levels in a system. Transient voltage surges or short-duration high-voltage spikes that can damage electrical equipment. Surge protection devices, SPDs, are used to protect equipment from transient voltage surges. Electrical testing and measurement are essential for ensuring the safety and reliability of electrical systems. Various types of test equipment are used to measure voltage, current, resistance, and other electrical parameters. Insulation resistance testing is used to check the condition of insulation in electrical equipment. Ground resistance testing is used to check the effectiveness of the grounding system. Electrical troubleshooting is the process of identifying and correcting problems in electrical systems. It requires a systematic approach and a good understanding of electrical principles. Safety is paramount when working with electricity. Always follow safety precautions and use appropriate personal protective equipment. This overview provides a foundation for understanding electrical engineering fundamentals. Further study and experience are essential for developing expertise in this field.